Hello team! Today we are going to have a very interesting lesson. We'll have both theoretical and practical part. It is very important for understanding of how enterprise applications work in concurrent environment. Today we are going to talk about locking, optimistic and pessimistic locks. Learning these topics is important because sometimes you would need to make a decision which lock to apply in order to optimize query execution and work with JPA entities in the system. We are going to start this lesson from understanding why we need locking. I will explain you what a database lock is. We'll review physical locks, logical locks. I will explain you different locking models in the JPA. Namely, we are going to talk about optimistic and pessimistic locking. We'll review version annotation and I will explain you why we need it. Also, I am going to explain explicit lock types and we'll review them on the example of LockModeType Enum. And specially for this lesson, I prepared coding demo that will help you to understand the topic better. So, let's start our lesson. Before watching this lesson, it is recommended you to watch lesson about transaction basics. The lesson is from my Java from Zero to First Job course, where we learned basics of transactions and about ACID, main requirements to transactions. Just to remind you that ACID stands for atomicity, consistency, isolation, and durability. Also, in some way, understanding of multithreading topic in Java will help you to build analogy with locking in the database. It is not absolutely the same, but as I said, understanding new topic with analogy is always easier rather than learning some new topic from scratch. This information will help you better understand the context of the lesson, but you still can proceed with watching this lesson. And now let's understand, why do we need locking? When we talk about Java enterprise applications, it is very important to handle concurrent operations to a database properly. So, we need to handle bulk transactions in a very effective and in a without error way. Also, we need to ensure data consistency between updates and concurrent reads operations. In concurrency theory, locking is used for protecting mutable shared data against data integrity anomalies. Because lock management is a very complex problem, most applications rely on their data provider implicit locking techniques. Delegating the whole locking responsibility to the database system can both simplify application development and prevent concurrency issues, such as deadlocking. But still, we need to learn how to work with locking programmatically in order to achieve better performance optimization and secure our JPA entities from lost updates and other concurrent interaction failures. Let's understand what a database lock is. In a database lock, only one database user, session, can update a particular set of data. A database lock prevents two or more users from updating the same piece of data at the same time. So, this is why databases have locks. Because imagine that two threads of execution in our program read data simultaneously, and both of them made updates. Which updates should be persisted in the database at the end? What rules should be applied in case conflict will be found? What should we do in case there is a risk of losing one update because another update will erase the first update made from another thread? Database lock should help us in answering all these questions by controlling access to the shared resource from different sessions or threads. A database lock is a mechanism that prevents or in other words, controls how the same data is used simultaneously. For example, we need to restrict simultaneous write access to the same row in the database to make sure that data will stay consistent. It is necessary to lock down data when multiple users access and update the same data at the same time. Locks are used as a means of synchronizing the access by concurrent transactions to the database item. Most applications tend to ignore thinking about concurrency issues during development. But at the end of the day, engineering team adds locking mechanism before going to production. If the application will have concurrent writers to the same objects, then the locking strategy is critical so that data corruption can be prevented. Locking is a mechanism that allows parallel work with the same data in the database. When more than one transaction tries to access the same data at the same time, locks come into play, which ensures that only one of these transactions will change the data. JPA supports two types of locking mechanisms, optimistic model and pessimistic model. Technically, there is a third strategy, ostrich locking, or no locking, which means put your head in the sand and ignore the issue. Just a joke. But before learning optimistic and pessimistic locking models, let's talk about physical locks first. Most database systems use shared and exclusive locks. For example, shared locks are used for reading, and exclusive locks are used for writing operations. Do you remember read-write log from JavaUtil concurrent logs package? Just as a comparison and analogy, let's remember it. Multiple threads of execution can obtain multiple read logs in case there is no write log obtained, because when we read data, we don't change its state. But when at least one thread obtained write log, we can't obtain read log, and we can't write simultaneously to the same object. That makes perfect sense. The similar things happening in the database, but instead of objects, our locking elements might be either rows in the tables or whole tables. While physical locking is demanded by the SQL standard, the pessimistic approach might hinder scalability. Modern databases have implemented lightweight locking techniques. The implicit database locking is hidden behind the transaction isolation level configuration. We are going to have a separate lesson about isolation levels and propagation during the transaction, so don't worry, we'll learn these topics too. Let's learn now more about logical locks and how they are different from the physical locks. If database locking is sufficient for batch processing systems, a multi-request web flow spans over several database transactions. So, in real life, in real business context, you would need to perform multiple interactions, including interactions with different database systems, to perform a single business valuable operation. For long conversations, a logical locking mechanism is much more appropriate. Logical locks can be configured programmatically. But today we'll focus our attention on the locking in the JPA. Let's discuss it. As a database abstraction layer, JPA can benefit from the implicit locking mechanisms offered by the underlying relational database management system. For logical locking, JPA offers an optional automated entity version control mechanism as well. JPA supports explicit locking for the following operations: finding an entity, locking an existing persistence context entity, refreshing an entity, querying through the GPQL, criteria or native queries. As I already said, JPA supports two types of locking mechanisms: optimistic model and pessimistic model. Let's learn the difference between these two models. In short, optimistic locking is when a record is locked only when changes are committed to the database, and pessimistic locking is when a record is locked while it is edited. In both data locking models, the lock is released after the changes are committed to the database. Let's learn deeper each of these locking models. Optimistic locking assumes that the data will not be modified between when you read the data until you write the data. This is the most common style of locking used and recommended in today's persistence solutions. The strategy involves checking that one or more values from the original object read are still the same when updating it. This verifies that the object has not changed by another user in between the read and the write. The optimistic locking model, also referred to as optimistic concurrency control. It is a concurrency control method used in relational databases that doesn't use record locking. Optimistic locking allows multiple users to attempt to update the same record without informing the users that others are also attempting to update the record. The record changes are validated only when the record is committed. If one user successfully updates the record, the other users attempting to commit their concurrent updates are informed that a conflict exists. An advantage of the optimistic locking model is that it avoids the overhead of locking a record for the duration of the action. If there are no simultaneous updates, then this model provides fast updates. Also, in case there are only read operations, optimistic locking works just fine. Optimistic locking is a useful approach when concurrent record updates are expected to be infrequent or the locking overhead is high. JPA supports using an optimistic locking version field that gets update on each update. The field can either be numeric or a timestamp value. A numeric value is recommended as a numeric value is more precise, portable, performant, and easier to deal with than a timestamp. The version annotation, or version element in XML configuration, is used to define the optimistic lock version field. The annotation is defined on the version field or property for the object, similar to an ID mapping. The object must contain an attribute to store the version field. The object's version attribute is automatically updated by the JPA provider and should not normally be modified by the application. The one exception is if the application reads the object in one transaction, sends the object to a client, and merges the object in another transaction. In this case, the application must ensure that the original object version is used, otherwise any changes in between the read and write will not be detected. When a locking contention is detected, an optimistic lock exception will be thrown. This could be wrapped inside the rollback exception or other exceptions if using GTA, but it should be set as the cause of the exception. The application can handle the exception, but should normally report the error to the user and let them determine what to do. The pessimistic locking model prevents simultaneous updates to records. As soon as one user starts to update a record, a lock is placed on it. Other users who attempt to update this record are informed that another user has an update in progress. The other users must wait until the first user has finished committing their changes, thereby releasing the record lock. Only then another user can make changes based on the previous user's changes. The main issues with pessimistic locking is that they use database resources, so require a database transaction and connection to be held open for the duration of the edit. This is typically not desirable for interactive web applications. Pessimistic locking can also have concurrency issues and cause deadlocks. The main advantage of pessimistic locking is that once the lock is obtained, it is fairly certain that the edit will be successful. This can be desirable in highly concurrent applications, where optimistic locking may cause too many optimistic locking errors. During the pessimistic locking, updates are serialized, and each subsequent update starts with the committed record changes from the previous user. Pessimistic locking is a useful approach when subsequent updates can be delayed until a previous update is completed. This usually implies that updates occur in a short time interval. Let's have a small demo now. I will explain you explicit lock types using the source code. As you already saw in the previous lesson, when we talked about basic operations with JPA entities, there is an API that allows us to specify lock mode type. For example, if you remember find method, there is an overloaded version that takes LockModeType Enum as one of the method arguments. There is also overloaded version of refresh method that also uses this enum. There is a separate method in the entity manager type that is called lock, to lock entity vividly. So, let's review now LockModeType Enum and understand a little bit more when we should use which enum. The first one in the list is read. Read is same as optimistic, just a synonym that you can use to increase readability of your code. Optimistic is obviously optimistic lock. Always issues a version check upon transaction commit. Today in the lesson I am going to show you how to set the version. Write is a synonym with optimistic force increment. Optimistic force increment always increases the entity version even when the entity doesn't change, and issue a version check upon transaction commit. Today we are going to see this on example. Pessimistic read is a shared lock that is acquired to prevent any other transaction from acquiring a pessimistic write lock. So, in simple words, many threads, many transactions can acquire pessimistic read lock. And while at least one transaction holds this lock, no one else can obtain pessimistic write lock. Everything is easy and logical. Pessimistic write lock is an exclusive lock that is acquired to prevent any other transaction from acquiring a pessimistic read or a pessimistic write lock. Exclusive lock means that only one transaction can hold this lock. And while this lock is held by a transaction, no other transactions can obtain pessimistic read or pessimistic write lock. Pessimistic force increment is a database lock that is acquired to prevent any other transaction from acquiring a pessimistic read or a pessimistic write lock, and the entity version is incremented upon transaction commit. And none means that there is no lock. And now, let's review the small code example that I have prepared for this lesson. In the package that is called locking, you can find again user class, entity manager helper, and demo class. Let me start from entity manager helper class. The thing is as we discussed in the first lessons when we have just started to learn what Entity Manager Factory and Entity Manager are. I told you that Entity Manager is not a thread safe, and using Entity Manager from different threads requires some extra attention. Taking into account that in this lesson I need to show you a multi-threading example, imitating multiple requests and multiple usage of Entity Manager from different threads, we also need to prepare Entity Manager for work in multi-threading environment. Considering that in this part of the course we are focusing on learning purely JPA and Hibernate, I am not adding Spring to our examples so far, because not necessarily you will use Spring on your future project, and anyway, you need to understand how JPA and JPA implementations work to have solid understanding and be able to fix issues in case of any. So, in this Entity Manager Helper class, I create one instance of Entity Manager Factory. That is fine, because it is recommended to have only one instance of Entity Manager Factory across all the app, and it is thread safe, so we shouldn't face any problems with that. And I create instance of thread local. Using Spring would make things easier because of the dependency injection management. Spring would handle all these things under the hood. Please check the section about multithreading in my Java from Zero to First Job course. In that section, we also learned what a thread local is. That's why I wouldn't stop on this too much. But in short, thread local object stores thread local variables. Basically, in each thread, there will be a different variable inside this object. This object, like a container, that will store different variables depending on the thread. You can imagine it like a map, where the key will be the name of the thread, and the value will be actually value associated with the thread. Using thread local, we can store Entity Manager specific to each thread. And here you can find some helpers methods. To get Entity Manager and close Entity Manager, to close Entity Manager Factory, and helper methods to begin, rollback, and commit transactions. Let me open now user class. Like we already discussed in the lesson, I created a field of int type that is annotated with the version annotation. Depending on the lock mode type that I am going to use, the version of the entity will be updated. And now I am going to show it to you. I open a demo class. We create one user and persist it. In the class, I use Entity Manager Helper that I already showed you. After that, I am going to execute this same operation 2 times in different threads. Let's understand what I do here. I get the reference to the Entity Manager. I start the transaction. I find the user that I have just created. And pay attention that this code will be executed 2 times in different threads. Is it clear? I use executor service to submit my tasks. And again, how to work with the executor service we learned in the multithreading section of my Java from Zero to First Job course. That's why I don't stop on this. So, each of 2 threads will have the reference to actually the same record in the database. Is it clear? Because each thread will find the same user. After that, I take the name of the thread for the login purposes. We change email of the user. New email will contain the name of the thread, and we will explore later what email will have our user at the end. After that, I call lock method on our Entity Manager. I pass the entity and lock mode type. I'm going to show you how our program will behave in case of the optimistic and pessimistic lock. and then we print which thread obtained the lock. It will be important for understanding the difference between optimistic and pessimistic lock. We commit our transaction, and also we print version and email. Here I put exception handler and print stack trace to console to show you the exception that will happen when we'll try to commit changes to the same entity from different thread. And at the end here, I just shut down execution service that I used to submit tasks to different threads and close Entity Manager Factory. Let's run now our application. The first run will be with pessimistic force increment LockModeType. And now let's investigate console output here. What do we have here? We see that the first thread was about to obtain a lock on user entity, and the second thread was about to do the same, and we can see that only one thread managed to obtain the lock. You can see that user version after commit has been changed, and in the email we have the name of the thread that managed to obtain the lock. What happened with another thread? Another thread has been interrupted by optimistic lock exception. Row was updated or deleted by another transaction. This exception in turn is caused by stale object state exception. Exception happened in the row 33 of this demo file. What conclusion we can make out of this? So, in case one thread obtained a pessimistic lock on an entity, another thread can't obtain pessimistic lock on the same entity. An exception happened during the attempt of obtaining such lock. Is it clear? Let me uncomment another type of lock. Let me run the program one more time, but this time we'll try to understand how optimistic force increment LockModeType impacts execution of our threads. Like we discussed, in case of optimistic lock, two threads managed to obtain the lock, but only one thread managed to commit changes. You can see this from log messages. Explore them too on your computer. You will be able to find the reference to this source code example in attachments to the video. And what happened with the second thread in this case? Let's find this out. This time we have rollback exception, error while committing the transaction, which is caused by optimistic lock exception. Row was updated or deleted by another transaction, which in turn caused by stale object state exception. But let's understand in which row. As you can see from logs here, this time exception happened in the row 37. So the error happened when I tried to commit transaction with updated entity that was updated already by another thread. So, can you see that exception happened on the later stage? That is because when we use optimistic lock, we still allow other threads to obtain the lock on the same entity. This is helpful for reading operations. For example, when multiple threads read information about my user, and neither of threads updates the user. In this case, there is no need to block access to the entity, but still, there is a need to prevent multiple updates from different threads in order to avoid cases when updates from one thread will erase updates from another thread. Is it clear? I believe that now it is more clear for you what is the difference between optimistic and pessimistic locking. Even in case you still have any questions, please do not hesitate to ask your questions below the video and I will be happy to answer. So, that's all what I wanted to discuss with you today. Let's recap what we have learned in this lesson. In this lesson we learned what a database lock is and why do we need it. We learned what physical locks are. I explained what illogical locks are. We learned locking in JPA. I explained the optimistic and pessimistic locking models. We learned explicit lock types in LockModeType Enum and saw the coding example. That's it for today. Thanks a lot for your attention. Have a great day and see you in the next lesson.